All right, everyone. My name is Karan Gupta, and today I'm here to introduce you one of the example, and particularly trying to let you know about Abaqus. So, how to use Abaqus in journal and how to accomplish all the element types. Examples, for example, starting with the very beginning with the civil application like the bar and trusses, as well as later we will see like beam also example of beams, as well as solid elements and some other shell elements also. So we will start with the solid mechanics part, where we will be only dealing with the displacement, deflections, stress strain analysis. So everything is going to be deal here. So this is a long series where the initial step or initial video is respect to understand how to use this software. And actually the point is like I also have a theoretical video. We will understand how exactly these parts are linked. So that will be uploaded along with that. And as of now, we'll start with a bar and trusses element. So what exactly the problem statement is? We just only have a bar element, and it's a unit meter long, and we are going to apply uh, load condition, axial load condition. So we will just simply see how exactly the interface works. So whenever we talk about the abacus, so one of the things that we have to understand is about the how we have to model it. So we have to go with this particular pipeline. So where we initially start with the part, then assign the property, assembly, that we say instances, step, where we applied the loading conditions, loading step condition. Then again, here we define the load, define the mesh, and that's it, and run the analysis. So we'll start quickly with the part here, and we have two panels. Either we can select it from here, or we can select it from the left side. So if I double click it, I can just simply get it. So it's a truss element that we are going to define. It's a 2D planar and it's a deformable, and the base feature is wire because we are only talking about one dimensional perspective. Approximate size is about the grid size, so it totally depends on your how much big your AutoCAD file is. So here everything you see is about CAD only, and there is nothing big. So you can see you can have the bigger grid or smaller grid as per the approximate size. Since I am just only talking about the bar element, so it's going to be here. So now it's free to move. So now since I only have like in x direction 1 unit, so it's 1 comma 0. So it's quite small, but this is what exactly we are doing today. Make it done. So our element part is created. Now we have to assign the property, and to assign it property, again we are taking it from here. We are trying to assign steel, and here at this material interface, we can define the density, and these are user defined manuals that we will see later. This is like all the mechanical part, elasticity and plasticity. So as examples goes on and on, we will see some more complicated part where we have plasticity also. And but right now today, it's only about elasticity. So very simple part of it. So elasticity, we only talk about isotropic, and then we define the Young's modulus. So let's say for steel, it is 200,000 MPa, and the Poisson's ratio is 0.3, is typical values. Nothing else we have to define, that's it, and we have to create a section. So make sure we are creating a truss part. So it's in general, all other videos will be more related to the solid elements, but today like it's more related to the truss. So we have to go to the beam, then we have to select truss and then continue. So this is how it assign the, you can just give any cross section area, it doesn't matter here. And now we have to assign the material to our part. So what we have to do is we have to just select each and everything, go done, everything is selected here, just click OK. Now you can see it's converted into almost so called like a green color. This means like everything is assigned here, the material is assigned to our part. Now it's assembly. So assembly, you can select it either from here, or you can just go downside. Probably if you can see like here assembly. Again, we have to click on the instances. So since we have only one part, so we are just simply going to say apply, and that's it. So we have given an instance. Now the another task is to give a step. So try to understand what exactly step is. So step is something like what exactly you want to do in your simulation. So let's say if you want to do some cyclic loading. So let's say you apply the load, you remove the load. This is what you are doing cyclic for one cycle, two cycle, three cycles. So this is what exactly you define here in the step. So it's a really critical thing that one has to understand while learning these softwares. So we have to define the steps. So make sure like the initial step is already defined. What does initial step means? Initial step means the prescribed or the initial boundary condition. So it is already defined here. What we have to do, we have to define our load boundary condition. The another step where we will apply a axis on the axis particular load, correct? So that's what we are going to define. So we double click here. So we are creating another step that is called load, and we can right now it's static journal, but as we goes on, if we will find out dynamic analysis and so on and on. So we click OK, and here again, like this is important aspect where we figure out the time period and incrementation, each and everything, but nonlinear geometry also. But as of now, we are just trying to learn very simple example. So that's it. We define a load here, and what else we have to do is we have to just give the all the loading condition. As I told you, like we have to give a load as well as we have to give a boundary condition. So initial boundary condition is, we all know, is what we have to give it on initial step, not on the load. So this load step, we have to give load for initial. It's already defined, already done for us. It's initial, and we have to give here like the displacement as well as rotation. So we can say this is a initial boundary condition for us, and we say continue, and we are going to give it here. As we can see, it becomes red. So it's done. Now make sure like for bar, truss elements as well as the solid elements, we don't have rotational degree of freedom. So make sure whenever you give the boundary condition for these elements, you don't have to give this UR3. For shell elements and for beam elements, we have to give like this R3 also, where we have rotational degree of freedom. But particularly for this type of element, we don't have it. For the sake, I'm just also putting U2, but doesn't matter. You can remove it, but you don't have to touch UR3 for these elements. Okay, so we have given a fixed boundary condition. Now we have to give another one, which is a load boundary condition. Again, see, for initial, we are not able to give any load. So what we have to do, define load and select the load step that we have created earlier. So I'm giving us normal concentrated force on this particular point is selected, shown as red. Now I just want to give 100 kilonewton or as much you want. It doesn't matter. Let's say it is 100 kilonewton right now, and I just give it here, so it shows the arrow, the direction. That's it. We only have to do mesh, and it is really important for us how to mesh the any of the parts. So what you have to do, we have to just go to the seed edges. Again, the error is because of we have to select a particular part. I have selected an assembly. It's not going to work here. Since now I have only one part, so truss part is selected. We have to go to the seed edges, select all, done. Now we can measure it by the size. So let's say if my element is 1 meter long or unit meter long, so 0.1 means I have 10 elements of 0.1 length. This is defined by the size, and we can also define by the number. So let's say if I define only 8 elements in journal, so it will do it accordingly. So this is the triangles are called the nodes, and in between we have the elements. So that's it, we are done with it. But the point is we have to also define the element type. That's what we will study in theory. It's S4R. And here again we have to select the family. The family is not beam, but rather than it is a truss. We selected. The geometric order is linear or quadratic. Totally depends, like respect the theory, like what exactly we have to select. For higher accuracy, we always try to select quadratic. So let's say I select quadratic. And now to define the mesh on this particular part, so right now we don't have a mesh. So to define it, we click OK to mesh the part. We say yes. And as you can see, the color changes, which means everything is all okay. Now everything is all done. We have to go to the jobs, double click here, submit it, and I say the first example for this. And we just create continue. And parallelizations and each and everything is like to boost your analysis. I mean the CPU power. This is where we use it. We will see it later. As of now, we did it. Okay. And we have to run this first example and we will submit it here. So everything is working here. It's going to complete the analysis and then we will see the post-processing part of it. So this is a really basic part of analysis. So this is how we start the series and we will learn some complicated part also. So stay tuned, and I would also recommend to go ahead with the theory because it's really important to understand theory before just understanding this. So let's go to the results. We can just directly see it from here. So this means like only the undeformed shape is plotted, but we can see the deformed plus undeformed with this respect. This is a one Mises stress, and we can just check it out the magnitude of the deformation. So as you can see, we have just pull it up in this particular direction. So higher stresses are there. You can also check it out the reaction forces. For sure, is going to be where we have the initial boundary condition, so on and on. So yeah, I mean, we can do a lot of post processing with this help, with this softwares, and this is a preliminary analysis to solve one uh, analysis so that you can boost up your confidence, and then we will see later beam elements also. So this is all about for truss elements. Thank you very much.